Okay, so we're looking at the nucleophilic substitution of haloalkanes to form alcohols in this instance. So here we have 1 bromopropane, 3 carbons, so it's prop, and it has the halogen on the first carbon, so it's 1 bromopropane. Note the conditions that we need for this reaction. Conditions are important. If we use the wrong conditions, we get a different product or no reaction at all. We're using aqueous sodium hydroxide or potassium hydroxide. Aqueous just means the solid has been dissolved in water. And when we do this, we get sodium ions, which are positive, and hydroxide ions, which are negative. And they are free to move about in the water, separate from one another. Now in nucleophilic substitution reactions, the sodium ion, or if it's potassium hydroxide, the potassium ion, are not involved in the reaction. They simply counter, they balance the negative charge of the hydroxide ions. We call them spectators because they're not going to play any part in the reaction, and in exam questions we don't need to show them in the mechanism in any way. Now in haloalkanes, the bonds between the carbon and the halogen is polar. That means that the electrons in the bond move closer to one end than the other, and they move closer to the halogen than the carbon. The halogen, the bromine in this case, is more electronegative than the carbon, and so it draws electrons towards itself. And the way we show this is by drawing a delta, it's a Greek letter, delta negative to show that the bromine has become slightly negatively charged, and a delta positive to show at the same time that the carbon is slightly positively charged. Now, along comes our hydroxide ion, and the hydroxide ion will act as a nucleophile. Now, a nucleophile is an electron pair donor. There's the lone pair. We'll show them, and you'd want to show them to an examiner in an exam question, so that you're showing you know that this is the nucleophile and it's going to donate its electron pair. Now, always in chemical reactions we follow the movement of electrons. So we have to look at the molecules and say, well, where are there lots of electrons and where can they move to? And in this reaction we've got the lone pair of electrons to start with, so they're going to want to attack somewhere else. And the obvious place for them to attack is the delta positive carbon. Obviously electrons are negatively charged, and so they're going to be drawn to this positive centre here, and they're going to attack there, and as they attack they form a chemical bond. In the process of forming this chemical bond, the carbon now has 5 bonds unless something else happens, and something else does happen. The carbon-bromine bond breaks. The electrons in that bond now go completely onto the bromine and the bond breaks. Now, if you were asked to draw this mechanism in an exam question on A-level chemistry, typically the examiner is looking to see you know 4 things. That your nucleophile has a lone pair of electrons, that you have identified that the bond is polar with the delta positive and delta negative the right way round, that you've drawn the lone pair of electrons attacking the delta positive carbon, and you've shown the bonds breaking between the carbon and the halogen. 4 marks usually are offered there, and we can just show we know what's happening by drawing the product. And in this case we're forming propan 1-ol. Again, the alcohol group comes off the first carbon, which is why we have 1-ol. and we're left with the bromide ion on its own. But remember, we still have this sodium plus spectator ion, which balances the charge of that bromide ion. Remember the conditions. Remember the 4 things you need to know about the mechanism, and make sure you know the product formed and the ion that's left over.